So in this video we will be having a discussion on resistivity and how resistivity changes with the temperature. Now resistivity rho is a proportionality constant, that is R is directly proportional to 1 by A, that we know, and R is equal to resistivity into A. So rho is the resistivity of the material that we had already established. Plus we had already had a discussion where we said that it does not depend upon the dimensions of the material but rather than the substance or the material property, say property. So this is what we had established so far. So now if you look at the temperature dependence of resistivity, what you will see is rho in terms of temperature T is actually equal to T naught, that is the initial, upon 1 plus alpha into T minus T naught. So this is what the relation gives you, that is resistivity for the temperature T. Now let's define the individual terms. If you want to define rho T, it is the resistivity at a temperature T. This is resistivity at temperature T. That is this. Say suppose what is the resistivity at 37 degrees Celsius. So T is equal to 37 degrees Celsius. So resistivity at 37 degrees Celsius is given by this rho 1 plus upon 37 minus T naught. So this is what the resistivity at a temperature actually means. Now T, for you, T is the temperature and T naught is the reference temperature. Is a reference temperature. Now, what is reference temperature? Reference temperature is, say suppose at a particular reference temperature you have, that is rho. You have, say suppose for 0 degrees Celsius, you know that this is your resistivity. So you need a reference temperature. In an examination or in different questions, your reference temperature will be given. They will say that we know from experimentation that at 0 degrees Celsius, the material has this much amount of resistivity. So this is your reference resistivity and this is your reference temperature. And all of this changes. Now if you increase the temperature to if you increase the temperature to T, your resistivity at that point is given by this relation. Now we have defined all the terms except your alpha. So what exactly is your alpha? Now alpha is called your temperature coefficient. Alpha is called your temperature coefficient. This is a temperature coefficient of resistivity. So this is what we know, the temperature dependence of a material or the change in resistivity according to your temperature. Now let's move further and see further derivations and calculation and the change of resistivity because of temperature T and some different factors in our next slide. Now say suppose if we are talking about resistivity, why do the electrons get resisted by? Now if you look closely, this electron suffers collision. This electron suffers collision because there is no free space. So because of this collision, they are not being able to move. Now under a particular electric field, they align themselves, but still they have these collisions. So that is why, let's say this is your average time. Average time for collisions. And we know resistivity is inverse of conductivity. The more resistive it is, the less conductive it becomes, and the more conductive it becomes, this is conductivity. This is resistivity. Name this as resistivity. So far we are clear about this particular concepts, resistivity and conductivity. So now if you look closely, you have resistivity is equal to M upon number of electrons, that is N into E square into average of time T. Now this is the relation that has been given to you. Now let's understand this relation. So if you look over here, M divided by E squared. Now this is a constant. This is constant, so it won't vary. Now all we have to understand is N. N is actually given as the number of free electrons. Number of free electrons in a given substance. So what we know is, since the number of free electrons in a given substance, that is, it's constant. No matter if you increase the temperature or you decrease the temperature, the number of free electrons of the substance is constant. So you can see that the more number of free electrons, the less the resistivity becomes. Also, this is T. This is the time period for collisions. This is the average time period for collisions. Let's name this time period for collisions. So now what we need to understand is that this is a time period and this is the number of free electrons. This is for collisions and this is your resistivity. Now if you increase the temperature, you know, the molecules start moving in a much faster rate. That is, they collide in a much faster rate because there is an increase in energy. And because of this increase in energy, what we can say is that this T increases. When temperature increases, this T increases. So when T increases, resistivity decreases. So we can say that when temperature, that is, it is inversely proportional to temperature. Rho is inversely proportional to temperature. So resistivity is inversely proportional to temperature, and this is what we can establish by this particular relation.